Hello out there, welcome to this tutorial on polar coordinates. In this video, we'll be looking at converting polar coordinates to Cartesian coordinates. So let's go. Given the polar coordinates of P as r, theta as shown in the diagram below. This is the pole and this is the polar axis. This is the point here, and this line is r and this is the angle the point makes with the polar axis. We call it a theta. If we complete this as a triangle, we are going to have a right angle triangle, and in this case this is x and this is y. The Cartesian coordinate of P is x comma y, where cos theta is equal to x over r. We are using the trigonometric ratios. Cos is adjacent over hypotenuse, and our adjacent here is x and our hypotenuse is r. And then if we make x the subject of the relation, we see that x is equal to r cos theta. This is very important. We are going to be making use of this to get the x coordinate of the Cartesian coordinates. Then also we have sine theta is equal to opposite, that is y over hypotenuse, that's over r. And then making y the subject of the formula, we have y to be equal to r sine theta. So this x equal to r cos theta and y equal to r sine theta are what we are going to be using to get our x and y coordinates respectively. So we go ahead to solve some problems. We are to express the following coordinates as Cartesian coordinates. For A, we have 2,60 degrees, B, negative 4,45 degrees, and C, 6,150 degrees. So we start the solution from A. So we have the formula here. So what we do now, we have to start with the x coordinates. Our r is 2 and our theta is 60 degrees, so therefore x is 2 times cos 60 degrees. Cos 60 degrees is 1 over 2, so we have 2 times 1 by 2 giving us 1, because 2 times 1 over 2 is 1. So for y coordinates, it is r sine theta. Our r is 2 multiplied by sine 60 degrees. Sine 60 degrees is root 3 over 2. So we have 2 times root 3 over 2. These two will go with this. We'll be left with root 3. We can then conclude the Cartesian coordinates are 1, root 3. And that's all for A. We go for B. Negative 4,45 degrees. We are still going to make use of this formula. We have x to be, our r here is negative 4 and our theta is 45 degrees here. Negative 4 times cos 45 degrees. This is negative 4 times root 2 over 2, because cos 45 degrees is root 2 over 2. If we simplify, this is going to give us negative 2 root 2. 2 will go into this negative 4 to give us negative 2, then multiply by root 2. Then for y coordinates, we still have negative 4 multiplied by sine 45 degrees. Sine 45 degrees is equal to cos 45 degrees, which is root 2 over 2. So negative 4 times root 2 over 2. And invariably it's giving us negative 2 root 2. So that the Cartesian coordinates are negative 2 root 2, negative 2 root 2. And that's all for B. We then go for C. For C, we still have our r to be 6 and our theta to be 150 degrees. So that the x coordinate will be 6 times cos 150 degrees. This is giving us 6 times negative root 3 over 2. For your information, this is in the second quadrant. Cosine is negative in the second quadrant. Is that okay? So simplifying this, I have negative 3 root 3. Then for y coordinates, we have 6 times sine 150 degrees. And in the second quadrant, sine is positive. So we are going to have it as 6 times 1 over 2, because sine 150 degrees is 1 over 2. Simplifying this, we have 3. So Cartesian coordinates are negative 3 root 3, comma 3. And that's all for solution of these problems, A, B, and C. And this is the highest we can take in this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.